So homework 16 has a lot to do with imaginary numbers. Way back before there were computers and TVs and all this good stuff, some guy named Euler was really bored, I guess, and decided that if you could do the square root of -1, you could do a whole lot more math. Otherwise it was undefined and you were stuck. So he decided to say that I was going to equal the square root of -1, and therefore I squared is equal to -1, the square root of -1 squared, which is just -1. So using those two simple rules then, he could do a whole lot more math, and what more fun could that be, right? Gavin agrees. So usually when I am simplifying something with a negative under the square root, I just take the I out right away and then worry about the rest of my simplifying. So if I'm going to simplify this one, I would have I square root of 33, and then I try to think about factoring the square root of 33 out to see if I can simplify that. Does 33 have any factors that are perfect squares other than 1? No, it doesn't, so I'm stuck, right? So on this one, I would say, okay, I'm going to have -I square root of 64. However, 64, I can do that one. Square root of 64 is 8. So I'm just going to have -8I then when I simplify that. So number 3, again, I'm going to take my I out and make it I squared of 80. 80 does have a factor, or more than one factor, that's a perfect square, but what's the biggest factor that is a perfect square? 16. I can make this 16 times 5, right? Square root of 16 is 4. So I'm going to get 4I square root of 5, and now I have it simplified. So on the next ones, the same kind of thing holds true. I'm going to take the i's out first and then start simplifying. So since I have square root of -66, I'm going to put it as I square root of 66. Since I have square root of -6, I'm going to do I square root of 6. Now when you reduce that fraction down, if it's on the outside, you can reduce together. If they're both under the square root, you can also reduce that. So here, the i's are basically just going to cancel out. The square root of 66 divided by the square root of 6 would be the square root of 11. Here again, I would make that I square root of 121 times the square root of 144, but then I'd want to simplify those. Those both happen to be perfect squares. The square root of 121 is 11, so that would make that 11I. Square root of 144 is 12, and so I'm going to take 11I times 12, which would give me 132I then, right? You treat that I just like you would an X in most cases when you're adding, subtracting, multiplying, those kind of things. So number 5, if I'm going to simplify that one, what should I start out by doing? Taking out the I square root of 13 times I square root of 7. Now I can't simplify the 13 or the 7, so now I'm going to do my multiplying. And so if I multiply those together, what would I get? I'm going to have in front I squared square root of 91, right? I squared is equal to -1, so I'm going to replace that with a negative and make that negative square root of 91. I don't think I can simplify the square root of 91. I can't think of any perfect squares there. The second one there, first starting out, taking out my i's, so I would have I square root of 20 over the square root of 10. And so if I simplify that, I'm going to get I square root of 2, right? It's 20 divided by 10. So number 6, again, both of those have the negatives inside, so I square root of 180 divided by I square root of 10. If I simplify that, I would get Are you just pondering or just waiting so you can just copy what I write? What happens with that one?
Square root of 36 and 5. And you just
How about I just divide? So the i's cancel, and 180 divided by 10 would be 18, so I get square root of 18. You could do, what did you have, 36 and 5?
I started breaking it down.
Oh, you started breaking them down? Well, you should get it down to the square root of 18. Square root of 18, can I simplify that? Yes, I can. 18 is 9 times 2, so I get 3 square root of 2 then. And the next one there again, that one has a negative, so I square root of 6 times the square root of 11. Can't simplify the 6 or the 11, so I'm going to go ahead and multiply, and I would get I square root of 66, right? Can't think any perfect squares that go into 66 either. This is going to be my answer then. Seven, 8, 9, adding or subtracting complex numbers. Like I said before, you treat it just like you would an X, and you'd combine your like terms. They're going to have you put your answer in standard form. For imaginary numbers, standard form is to put the real number part first and the imaginary number on the end. So it looks like these, 6 minus 2i. Normally when we work with x's, we put the x's in front and the numbers on the end. But we're just going to combine our like terms. Here we're adding, so 6 plus 4 is 10. Negative 2i plus 3i is 1i, which is just a positive I then. So 10 plus I is just going to be my answer. When I subtract, I can either think of it as subtracting or adding the opposite. So I could do 4 minus 6i and distribute my negative. So negative 6 plus 4i. And then I'm combining my like terms again. 4 minus 6 is negative 2. Negative 6i plus 4i is negative 2i. So negative 2 minus 2i. So number 9, when I do that one, what should I do? Distribute my negative. So negative 3i plus 2 minus 4i. Combining my like terms then, my answer would be or 2 minus 7i. And so they want to make sure you put it in standard form, so here the order is going to make a difference when you put your answer in because they're picky. The multiplying again, we're going to multiply it out like we would normally with x's. One little thing we want to watch for, if we have an I squared, we're going to substitute in our negative 1 and simplify it farther. But first of all, we're just going to multiply it out. So negative 3i times negative 4i would be positive 12i. Negative 3i times positive 2i would be negative 6i squared. The I squared, they're just going to replace with a negative 1. And so a negative times a negative is going to make that a positive 6. So I have 12i plus 6, but then I want to make sure that I put my answer in standard form. So 6 plus 12i is how they're going to want you to put your answer in. So number 11, same kind of thing. I'm going to FOIL that one out first. So negative 3 times negative 4 is 12. Negative 3 times 3i is minus 9i. 6i times minus 4 is minus 24i. 6i times 3i is a positive 18i squared. So again, in for that I squared, I can put in a negative 1. Positive times a negative would just make that negative 18 then, and got rid of the imaginary part of that number. I'm then going to combine my like terms. Since they want it in standard form, I want to do my numbers first. 12 minus 18 is negative 6. Negative 9i minus 24i minus 33i. So number 12, if I'm going to multiply that out, what would I get? $30. Minus 30i. Minus 20i. Plus 20i squared. I'm then going to do what?
Negative 20.
Make that negative 20, since I squared is equal to negative 1, and then combine my like terms. So my answer,
10 minus 50i.
10 minus 50i. 13, we're dividing, and you want to think of this as a square root. And when we get rid of the square root, we multiply by the conjugate. When you do the conjugate, you're doing the opposite of the I part of it, right? If I have negative 2 minus 5i, it would be negative 2 plus 5i. So when you only have one term there, you're thinking of it as 0 minus 4i. The conjugate would be 0 plus 4i, which would just be 4i, right? So we're going to multiply the top and the bottom times 4i. So distributing on the top, negative 5 times 4i would be negative 20i. Negative 3i times 4i would be negative 12i squared. Almost right's where I want it. Since I have that I squared, I can put in my negative 1, and I'm going to have 12 minus 20i, since I want it in standard form anyway. On the bottom, negative 4i times positive 4i is negative 16i squared. And again, we're going to put in the negative 1, and so a negative times a negative is going to make that a positive 16. Now, when they put their answer in standard form, they're going to separate the real number part from the imaginary number part, so they're going to put two fractions in this case. If I have 12/16, I can reduce it down to 3/4. And if I have negative 20/16, I can reduce it down to negative 5/4, and they're going to put the I on the end behind it. So my answer in standard form would look like that. So on number 14, we already talked about the conjugate of negative 2 minus 5i being negative 2 plus 5i. And this time we get to FOIL all of that out. So on the top, if you multiply that out, you would get
Negative 8 plus 20i plus 4i minus 10i squared.
I can't write that fast. Negative 8 plus 20i is then plus 4i
minus 10I squared.
minus 10i squared. You put negative 1 in for your I squared and you combined your like terms, so you got 2 plus 24i on the top of that fraction. On the bottom, if we FOIL that one out, we would get Beta's just waiting to answer. 4, what was that?
Minus 10i.
Minus 10i
Plus 10i.
plus 10i
Minus 25i.
minus 25i squared. Again, we put the negative 1 in. My middle term should cancel out. That's why I use conjugate. So on the bottom of that fraction, I'm going to have 29, right? 4 plus 25 is 29. Again, they're going to have you separate that, so you're going to have 2 29ths plus 24 29ths I. And so number 15, if I'm going to multiply by the conjugate, I'm going to multiply by 5 minus 6i. So using my distributive property on top, I would get 30 minus 30, whoops, 30i. 30i minus 36i squared, right? I squared is equal to negative 1, so that makes that a positive 36 plus 30i if I put it in standard form. On the bottom, if we multiply that out, we would get
25 minus 36i squared.
25 minus 36i squared, because we know our two middle terms are going to cancel out anyway. And so if we substitute in our negative 1, 25 plus 36 would give me 61, I think I heard you whispering. 36 over 61 plus 30 over 61. I can't reduce those down, I don't think. So that would be my answer. And the last three on this page is simplifying when you have a higher exponent. And so what they're going to do is have you rewrite it in terms of I squared so that you can substitute in negative 1. And so they're going to first of all take 2 and divide it into 35 using the long division with the remainder like we did way back in, I don't know, 3rd grade probably. So 2 goes into 35 how many times?
1. Oh, 35.
1.
I was thinking just 3.
And then 2 goes into, yep, 15. 7. And we get a remainder of 1. Yeah, we probably would have did it the long way when we were way back in grade school. So we would write it as I squared to the 17th power times an extra I. This would be 34 plus 1 more is 35. I squared then is negative 1. And when you take negative 1 to an odd power, it's going to stay negative 1, right? Negative 1 to an even power becomes positive 1. But this stays negative 1 times I gives me negative I for my answer then. There's only ever going to be 4 possible solutions. You're either going to get I, negative I, 1, or negative 1. Anything other than that is not going to be correct. So if I have I to the 24th power, I can write it as I squared to what power? The 12th. This 2 goes into 24 12 times with no remainder. I squared again is negative 1, and if you do negative 1 to the 12th power, you get positive 1. So 1 is just going to be my answer. So 18, we're going to write it as I squared to 26. That gives me 52, so I need that extra I on the end to get to my 53, right? I squared to the 26th power. Negative 1 to the 26th power is 1, and 1 times I just gives me I then for my answer. All right. It's probably as much as they're going to do with imaginary numbers.